I'm here to talk about question number 1 and 2. Regarding question 1, the main key features that I can think of that we can do to increase the sales of the vehicle and make it more efficient is that we can increase the battery life so that once charged the vehicle will run for a longer period of time, and also decrease the charging time so that right now the vehicle takes more than 6 hours, so preferably the vehicle will get charged in less than 4 hours of time, so that it will be easier for the user to just charge their vehicle quickly and be on the move. Second thing we can do is add a feature to register your documents on your vehicle, so that when we say documents we mean your driver's license or your vehicle papers which you need easy access to in case of emergencies. So that will be a very big plus point. Another thing that we can add is user interface changes that the user can make. For example, you can add dark mode in night time, or just change the brightness of your screen, or change the theme or the colors during the day as per the user preferences. One more thing that we can do is smart alerts. We can have an app connected to the vehicle which can send the user smart alerts regarding the battery life. For example, if the battery is running low, so the user will be notified immediately, and they'll also know how far their vehicle will travel, so that they can easily access a charging point and just not get stuck in a difficult situation. We can also do real-time navigation. We can connect with Google Maps so that the user can drive easily without having to check their phones or any other device while driving to check Google Maps, and they can just have that facility in the vehicle itself. For the second questions, we're thinking about design considerations for different features. So for functional design, we can see that the vehicle supports different file types. That can be pictures in the form of JPGs or PNGs. It can also be documents. It should also have multiple upload sources. It can have a gallery, it can have a cloud. The cloud can be Google Drive or iCloud or whatever else. It should also be accessible from a vehicle tablet, so that the user can read everything that is on their vehicle from the dashboard that is present on the screen. And as far as security considerations are concerned, we should have end-to-end encryption, so that the data is always encrypted during upload or download, and also while at rest. We can also have multiple factor authentication, so that the user always feels safe that their data is well protected. And we should have role-based access control, so that admins will also have access to certain features, but the users will also have help when needed. We should also audit our logs frequently, so that we can track documents and have easy access. So that's fine.
So now let us discuss about the problem statement that the vehicle does not seem comfortable on cement roads or on gravels at very high speeds. So what could be the problem over here? So I can think of 3 to 4 reasons. First one is that the suspension system might not be optimized for rough terrains, or that second case can be that poor shock absorbing design or materials may be used. Third is that the wheel or the tire selection may not be optimized for suburban areas or for off drifting. And number 4 is can be due to poor weight distribution, which can impact the overall vehicle stability at very high speeds. So to overcome these problems, we can simulate testing scenarios. First one can be suspension testing. We can simulate rides over different types of roads, that is cement road, dirt road or gravel road, and we can measure the vibrations with vibrating sensors, and most importantly the rider's subjective feedback. Secondly, we can perform a weight balancing test. We can measure the impact of the overall distribution of the weight over the vehicle's center of gravity, which may impact its control and hold over the road. And lastly, we can also perform a durability test, where we can measure the wear and tears on the tires, suspension, and chassis over thousands of kilometers of non-tarred roads, that is, dirt, gravel, and cement roads. So now another problem is that customers often complain that around the poor performance of the battery. That is, customer have observed that the scooter takes longer to charge as it gets older, and more worryingly, it seems to shut down without giving any prior information or prior warning. There are several potential reasons for this. Firstly, it can be due to current power management algorithms does not seem to accurately account for the battery degradation over time. Secondly, it can be due to some diagnostics of the battery health might be unreliable, causing some misleading charging indicators. We also find that the vehicle lacks the true smart battery management system, or BMS, that is called. So over time, the charge discharge cycle calibration also drifts, meaning that what used to be known as full charge is not at its 100% level and can be reduced down to 80 or 70%. So to address this, we are proposing 4 key test scenarios. So firstly, we will do some battery life cycle tests to simulate around 300 full charge and discharge cycles. So then a charge predictability test, that when we will compare the estimated and the usual battery charging performance when the charge drops below 20%. And we will also perform a warning system test where the riders gets timely alert when the battery is low and timely indicates them when they need to charge to avoid any further future consequences or their overall user experience. And also we will measure the overall temperature of the scooter or the vehicle, and also the rider's behavior to give some more extra accurate feedback. So another problem statement is that the company would like to have the app to have some intelligence and provide some recommendations to the driver on what kind of data should the app collect from the vehicle and what kind of recommendations can be done. Is there a possibility use of ML or AI of this analysis, and if so, then how can we use this in cars? So to make the app more intelligent and rider friendly, it needs to be collect some key data insights from the vehicle, such as battery health, speed, terrain types, GPS, rider's habit, and overall charging and discharging patterns. So using this data, the app can offer some smart features and smart insights over the overall users use of the vehicle and the vehicle's response to it. We can also see some potential strong benefits from using AI and ML here. For example, predictive maintenance can catch the motor or batteries issue earlier. Adaptive range prediction can adjust based on how well and how far the driver usually rides. We can even suggest some best timing to ride based on the charging pattern and the behavior of the local tariffs. To boost the user's engagement, the app can also include the rider's efficiency score and voice-based tips, or basically we can gamify, sounding it more interesting and engaging.
So I'll be talking about the fourth question, which is the use of inside out and outside in techniques to release a product. So inside out basically means a company centric focus, which means that we're going to use the internal capabilities of the company. So what we're going to do is we're going to redesign the app's tech architecture to make sure that the backend can handle the queries, and this will fix the major complaint about the outdated data and delayed information. We are also going to revamp the UI UX to make sure that the UI is clean, intuitive, and user friendly. We're also going to develop a robust notification engine, making sure that all alerts, especially for low battery or charging status, are pushed in real time with zero lag. We are going to conduct thorough internal testing to make sure the app runs smoothly on various devices and OS. We are also going to have a smooth integration with the tablet dashboard to make sure that everything is in perfect sync. Outside in planning basically means a more consumer or market centric focus. So what we're going to do here is analyze past customer feedback, benchmark against competitors. We're going to study the top electric scooter apps or electric scooters in general to understand what they do better. Launch a beta program. So we are going to launch a beta testing program to make sure that we know what the customers really need and they know what they can expect from the app. We're going to design it for real-time scenarios. For example, we're going to allow offline maps for areas with low connectivity, etc. We're going to also build a strong go-to-market story. Like we're going to highlight how the app solves real pain points like faster updates, better UI, etc. The question 5 is about how we're gonna list the top 10 features, and we're gonna prioritize them on P1 and P2. With P1 meaning that it is a must-have essential feature, and P2 meaning it is nice to have but not necessary. So fast charging is definitely P1, a must-have feature. Lightweight scooter is again a P1 feature, a must-have. User-friendly UI, app UI, is a must-have feature because it was a complaint. Real-time notifications is a must-have feature. Google Maps integration is again a must-have feature. Tablet touchscreen dashboard is a P2 feature, a second priority feature, which is nice to have. Document upload is again a P2 feature. View documents on dashboard is a P2 feature. Zero operational bugs at launch is again a P1 feature. Battery drain prediction is a P1 feature. Thank you.
Question 6. So my question is about why the company is having trouble with the data going from the scooter to the cloud and then to the app. Basically, the data updates are slow or sometimes don't show up correctly on the app. We think there could be a few reasons for this. Firstly, the network issue. For example, if a scooter is in an area with weak internet or mobile signal, it might not be able to send the data properly. Or there could be second issue could be backend problems. For if the cloud system isn't well organized, optimized, it might be slow to process and send back the information to the app. Third problem I think is bad syncing method. If the scooter sends data in big chunks instead of small regular updates, the app might show outdated info. Question 13. This question is about the business and engineering metrics the company might be using to decide what to fix or improve. So from a business point of view, they're probably tracking sales numbers since they want to increase sales by 50%. Customer complaints because it's important, especially around comfort, battery, and app issues that the customers have reported. Third could be profit per vehicle as they're currently in loss. They are currently in loss. Fourth could be the market share since they want to go from fourth to second place. And on the engineering side, on the more metric and scientific side, they could be measuring battery performances like how long it lasts, how fast it charges, what's the output, uh, what's the output. Then app responses time and even data accuracy since user complain it shows wrong info. Then also the weight of scooter as the scooter itself is heavier than its competitors, and even the number of reported issues in the first few months after launch. These metrics help connect what users are unhappy with what the team needs to actually improve on in the product.